Hello all, welcome to another session on Java programming. In this session, we'll be taking a look at generic methods and classes in Java. So the topic for today's discussion is generic methods and classes in Java. So what is the use of a generic method? It is used for code reuse. So you write a generic method once and you can use the same method with the different data types. And the same thing applies for classes too. So code reusability is one of the important advantages of generics. And another advantage is that you will be able to catch some errors during compilation rather than having them during your runtime. So we'll take a look at all these things with certain examples here. First, I will give you an example without a generic method. We'll understand how we can reuse code by having a generic method by applying the concepts of generics later on. So now let's take up this example. Let me have this very simple display method. So what this method does is it's a simple display method, public static void display, and we're going to display a string here, get the input as a string, and then we'll display this string to the user. That's it, a very simple display method. And let me call this display method here, and then let me pass a string. Let me give my name here. Let's execute this. So you'll be able to see the output as Satish, because we are passing the string to this method, and it's a very simple program. Say if I have an integer value, int a is equal to 2, and then if I want to pass this integer value to a display method and then display that, then what I should be performing. So again, I should be coding this method, that is public static void display, and it's going to accept an integer value as the input, say int input, and we'll be displaying the integer value out. So sys out input. So this method is going to accept a string and this method is going to accept an integer. So we need two different methods for these two different data types. I hope you all agree with me. Let me pass a here. Okay. So now when we execute this program, first this display is going to be called, and then for display of a, we're going to have this method that accepts an integer as an input will be called. So we're going to have two different methods for two different data types. So if you're going to have float, you're going to have double, you're going to have different data types, and you have to have different versions of the display method. So if I want to display a float variable, again I should be going with this static void display, and then I should accept a float variable as input, and then I should be displaying this float variable out to the user. So it's input. And say if I am passing, say if I have float variable k is equal to 123.02 f, and I'm just calling display and passing the float value here. So now for different data types, I should have the same version of the method that accepts different data types as input. So when I run this, you'll be able to see. So this is the float value, this is for the integer value, and this is for the string. So what is that we understand here is we are writing the same method again and again, and the purpose of this is to get in an input of a certain data type and display that and print that. So how generics helps us, say instead of writing separate methods, we can just have one generic method. I'll tell you how to write the generic method. So we are going to get a generic input, that is, we'll say s is of type generic, that is, let it be integer, let it be float, let it be string, whatever it is, we'll be getting that as input. And we say this method to be a generic method that accepts an input of generic type, and we'll be just displaying this. So we're just having one generic method here. So we call this to be a generic method. And we don't need a separate methods for different data types. So we have coded this generic method. Now, in what way this generic method helps us? Say when you're passing a string, the type or the type of s will be a string here. So t will be taking up strings. And when you're passing an int, so t will be mapped to an int. When you're passing a float, t will be taking up the type float. So automatically, whatever data types you're going to pass in, that will be carried on and to this, that will be mapped on to T, and then S will be of that specific type. So once when Satish comes in, Satish is of type string, so T is going to be taken up as string. So this method is going to accept any kind of data types, and it depends on the kind of data you're passing. T will be taking up that specific data type. So let me run this. Let's see the output. So you're able to see here that we're getting the same output as we did with our earlier example without a generic method. One of the advantages here is code reusability. You can very well see the number of lines of code we have written is less. We don't have many methods for different data types, and we're just using one single generic method for all the types of input that we are giving in here. So that is the use of generics, and I hope you all have understood how generic method helps us with code reusability. Now, the next question is, what if I have multiple parameters to my method? For instance, this method accepts two strings or two integers or two floats. In that case, say if I have two strings coming in, I'll say T and let's have R here. So we have two parameters coming in. So I'll also be printing out R. So likewise, here I should be passing in two parameters, say RAM. I can also pass two integers, a is equal to 2, c is equal to 3, and then pass a comma c. Likewise, we can have another float value here, h is equal to 1 to 5.06f. And then I can pass another float value here. So it is k comma h. So what is that we are understanding here is, when you have multiple arguments of the same type getting passed to this method, then we are going to mention that as T, this is the first parameter that's coming in as input, and R, and this is the second parameter that's coming in as input. So the type of Satish will be mapped to this T, and the type of Ram will be mapped to this T. So obviously this will be string S and string R for this method call. And for this method call, T will be of int and this T will be of int. And for floats, obviously we'll have this T to be a float and this T to be a float. And when we print the output, you'll be able to see the results for all these different method calls. So we're able to achieve the output. So when you have multiple parameters and you're passing in the same data types, you can very well mention that like this. So there can be a question in your mind: what happens when I have different data types? Say I want to pass an string and then an integer like this. Then what should be the approach for that? Say, let me tell you. Let's take one example here. Say if I have a string and then an integer, what is the convention is, you should say this is a different data type that's coming in, and we are going to use two different data types with this method. So this is the convention that we have to follow, just to mention that T is different from U. So we are going to get in an input that is, first one is a string and the next one is an integer. So this is of type string and this is of type integer, right? So we are getting two different data types. So we mentioned that with two different variables here, T and U. So that's how you handle generic methods with different input types. I hope you're able to follow me. Okay, that's about generic methods. Now let us move on to generic classes. So the next discussion we are going to have is on generic classes in Java. So let's talk about generic classes in Java. As usual, I'm going to just give an example without using generics, and then we'll see how generics helps us. So let's take up this simple class test, and we'll have a string, say element 1 to be a string, and the string element 2. And what we'll do is we'll have a constructor here, and in this constructor we'll be getting in a string as input. So input element 1, It's a parameterized constructor, and a string input element 2. And what we do here is we'll just initialize this dot element 1 is equal to input element 1, a simple parameterized constructor here, and this dot element 2 is equal to input element 2. Okay, so we have a parameterized constructor and we have two elements here. And what we can do here is its input element. I have a spelling mistake here. Okay. So we'll also have a method to display the data out. So we'll have public void display method here. And what this method does is just displays the data out. So it displays element 1 and it also displays element 2. I hope you all have understood this simple class, a class that takes in two strings and it has a parameterized constructor, gets in the strings when we create the object, and then we have a display method to display the values. Now, if I want to create an object for this, how will I create an object? It is a test. I'll say yes is equal to new test, and we have to pass two strings. Let me pass my name Satish and Vellore here. Now, if I want to invoke the display method, it's going to be s.display. This is a very simple class, and you see it's going to work fine. So we'll be getting the display as Satish and Vellore. Very simple class. Say if I want to pass two integer values and create an object for this class. If I want to pass two integer values, if I want to reuse this class for two integer elements, say like this test, s is equal to new test. I want to pass 1 2 3 comma 2 3 4. So immediately you can see there's an error popping up because we are passing integers here, whereas what we require is a string. So we can't use this class for other data types. We can't create objects that can take in other data types. So how we can write up a generic class that will work with different data types is the question. So what we'll do now is we will convert this class test to a generic class. So now, how to convert this class to a generic class? You see the number of input types it's going to take. So we are just passing in strings. That's just one input type. So we can say we are going to get one specific input type as input while we are creating an object for this class. And all that we'll be doing here is element will be of type T. We'll make it generic. It's not string, it's generic here. It's of type T, and whatever input that is coming in will be of type T. So we are making everything generic here. That's it. So we have coded a first generic class that will be taking in one input type, and then we'll map those types to these elements, and we'll also display those elements back. So now let's take a look at creating an object. See, once when you made this to be a generic class, you're getting in some type safety issues here. So how to fix those issues, how to create an object for this classes? You create an object of type test, and then you have to pass the type of inputs you are going to give. Say I'm going to give string as an input, then I'm going to say it's going to take inputs of type string, and I have to pass strings here, say Satish and Vellore. So now I'll call this object name to be S. So when I create an object, so this class, this T will be mapped to a string. So it's going to take in an input of strings. That is the meaning. So obviously this will be converted to a string. So wherever you have T, you'll have strings there. So this is a string, this is a string, this is a string, this is a string. So when you say we are just creating an object that will be mapped to strings, it means that you're taking the element T to be of type string. And let's display this s.display, and we'll see how this code works. Okay, it works the same way as it did without the generics. I hope you all have understood this. And now if I want to pass an integer value and then create these objects, I want to pass two integer values and create these objects. Now the input type is integers. See, please Be cautious here. Do not use any primitive data types. Generics works only with objects. So you have to mention it as integer. S is, I'll say it, this is K is equal to new test. And what is the type I'm passing in? It's all going to be integers. And now I can pass the integer value, say 1, 2, 3, 3 to 4. And I can call k dot display. See, earlier, without generics, we had an error at this stage. But right now, we'll be able to pass in two integer values, and we can reuse the same class for our output. So what's happening here? When I say it's an integer, the value of t is mapped to an integer. So it's integer element 1, integer element 2, integer input element 1, integer input element 2, and we'll be able to achieve the output. So we are going to use the same class for two different types of inputs. One is a string and another one is an integer. So you see, that is the important, that is the significance of generic classes. You'll be able to do a lot of code reuse here. I hope you all were able to follow this. Now comes the next concept, that is, what if I have a class that takes in two different input element types? Say for instance, you have a string here and you have an integer here. So one element is a string and another element is an integer. This is a string and this is an integer. So in this case, how you're going to convert a class having different element types into a generic class? It's very similar like the methods that we have taken. Say how many number of types you're going to have here, two different types. So I'll say t and u. Wherever I'm going to have string, I'll say that is t. Wherever I'm going to have int, I'm going to say that's u. So t represents one specific type and u represents another specific type. So we can say element 1 is of type t and element 2 is of type u. So here input element will be of type t and input element will be of type u. So this is how you create a generic class that is having data members of different types. And how do you create an object for this? Say I have to pass a string and an integer, or it can be an integer and a string. So we have to pass in two different types. Then how to create an object for that? So for this, what we are going to do is we'll create an object. I'll show you. So it's test. What we are going to pass first is a string and next one is an integer. Likewise, what are the values we are going to pass? First is a string and next one is an integer. Works perfectly fine. And the object here is, let's say s, and I'll call s.display. Okay, let's run this code. Let's see what's the output here. Satish 1, 2, 3. So how this one worked? This is a string. So t will be taking the type string and integer is getting passed. So u will be an integer. So you can say this is string element 1, integer element 2, string element 1, integer element 2. So when I pass a string, this is going to be of string. And when I pass an integer, this is going to be of type integer. And that's it, our generic class with different data types. We have defined that and we have used this. Let's see how this is very useful. You see, I can very well create an object like this. Let me create an object test. I can now pass in an integer first or a float first, whatever it is, and then I can pass a string. So now this object, I'll call that to be k. See, I can very well reverse the data types, right? 1, 2, 3 and Satish I can give. Now if I call k.display, you see it works perfectly fine because this is a generic class, right? So it accepts any input types. So what's happening here? Now this integer is mapped onto t and this string is mapped onto u. So you'll have integer element 1, string element 2. Likewise, this one we are getting in here is an integer input element 1 and a string input element 2. So this class works for any kind of data that you're passing in. The only thing you have to keep in mind is you have to mention what is the kind of data that's coming in, the type of the data that is coming in. So t and u will be taking in the types in the same order that you are specifying. I would like to wind up this session with one more simple concept, like how to limit a class or a method with the kind of input that will receive by using the extends keyword. Let me use a simple method for this and then I'll explain you what is that. So let's say I have this display method public static. It's a generic display method here. Void display, and it's a generic method, so it takes in some input, and we're going to have a sort statement will display the input that's receiving. Now I have this input. Say I can very well display a string. So I'll be able to pass a string. I'll also be able to pass an integer value I wish, and I'll also be able to pass any float values I wish. So this method is going to work perfectly fine because it's a generic method. We all know this. Now I want to limit this method to accept only subclasses of the number type. For instance, extends number. So what it means, this method will not be accepting anything that is not a subclass of the number type. So what are the subclasses of this class? Let's take a look at the subclasses. So we have all these classes: integers, float, byte, all these classes to be subclasses of the number type. We'll be able to verify that if I open the declaration for integer, integer extends number. Likewise, when you open the declaration for float, float extends number. And when you open the declaration for byte, you'll be able to see byte extends number. By just saying I want a method that will work only with the subclasses that actually extend this number class. So by this way, I'll be able to limit what in the sense, limit this method to accept only objects of the subclasses of number type. So we are just going to have only subclasses that extend number, only those objects to be part of this. String doesn't extend number. That's why we are getting this error. Why we are getting this error? String is not a subclass of number. Since string is not a subclass of number, you see you're getting an error here. Whereas I'm not getting an error with these two calls because integer is a subclass of number and float is a subclass of number. Let me run this code and show you. See, it works fine. But on the other way around, if I try to pass anything that is not a subclass of number, then I'm going to get an error with this. So we can also use the extends keyword. We can very well say what type of object that comes in as input is allowed for this method. So we can very well use this extends keyword to limit the kind of input that comes into our generic method or the generic classes too. I hope you all have understood the concepts on generic methods and generic classes. Now let us take a very simple exercise and then we'll wind up. The exercise is a very simple exercise. Now let's take a very simple exercise, that is create a generic method that will accept an array of objects. Say this can be an array of student objects, an array of course objects, whatever it is. It is a generic method. It should accept an array of objects, user defined objects. And I'll say it's an array of user defined objects. And what this method should do is display the contents of the array. So it should display the data members for the objects in the array, or else I can say display the data members for the objects in the array. So let me take up two classes. Class students, we'll have string name and say int mark, and we'll have a parametrics constructor here. Source generate constructor using fields. We'll generate a constructor, parametrics constructor here. So this is for the students, and we'll also have another class course. We'll have a string course ID and string course name. And we'll also have a parametrics constructor here for this course class. So that's generate constructor using fields generate. So constructor is generated. So we have two classes, two simple classes. We need to create an array of objects. So let's create an array of student objects. Let's say students. It's an array of student objects. S is equal to new students. I'll hold two student objects in my array. And let me create directly. Let me create. I'm not going to get the user input here. S of 0 is equal to new students, and then I'll pass the student name Satish, and input type is, I mean, the marks to be 12, something like that. And let's have another object. S of 1 is equal to new students, and we'll pass the name as Ram and marks to be 55. So two student objects we have created. Now let us create an array of course objects. So course C, it's an array, is equal to new course. And this is going to hold two course objects. Let me directly create the course objects here. So we'll say course of 0. The first reference will be pointing to a new course object. So we'll say the course is Java, and then the course ID and course name, I guess. Course ID, say its course ID is 123 and course name is Java. Likewise, we'll have the next course, that is C of 1 is equal to new course. So course ID is 124 and course name is say OS. So we have created an array of objects for course, and we have created an array of objects for students. Now we need to perform like this. I should call this display method, pass the array of student objects. I should be able to use the same generic method and pass the array of course objects. So this generic method will accept student objects as well as course objects. It will display the contents, the data members for the students and the data members for the courses. So how to code this generic method? Let's start off with that. So it's a public static. So it's a generic method accepting an array of objects, and it's void display. So this is a generic type, and it's an array that's coming in. Let's say it's S. I'll just say it's input. So it's an input array that we are receiving in. When I'm passing in array of student objects, T will be of type students, and it's an array of student objects that's coming in. When I'm passing C, T will be of type course, and it's an array of course objects I'm getting in. So how will I print all the course objects and student objects? I have to get every object. Every object I'm going to get, say, obj from input array. So this is like first I'm passing the array of students. So I'm going to take every student object, and I'm going to check whether it is an instance of object is an instance of students. So I'm going to check this. If object is an instance of students, if it is true, then I'll be able to print this out. So it's going to be the object which is of type students. So let's do a typecasting here, and I'll be able to print the name. So you have to perform this object dot name, right? And I'll also be able to print the marks. So let me copy this. So we should typecast this and print the marks for the students dot marks. Okay, so this is for the student objects that's coming in. If I'm going to get an array of course objects, say if this is an instance of course, then what I'll be able to print, it's going to be course object dot, it will be course ID, I guess, course ID, and this is going to be course object dot, this is going to be course name. So what we are doing here, this method is going to get an array of objects. It's a generic method. It doesn't care whether it's an array of students, an array of courses, array of faculty. So it's going to get the array of objects, take in every object on this input, check if it's an instance of students, then print the corresponding data members for the students, check if it's an instance of course, and then you print the corresponding data members for the course. Let's run this. Let's check whether our generic method is working fine. Yes, so you see here, first we have the student 1 and student 2, name and mark, then course 1 and course 2. So we have coded a generic method that accepts an array of objects. I hope you are able to understand how to write generic methods and generic classes and how they help us with respect to code reusability.